Hey guys, it's Fen. In this video, I will try to show you a new structure that I want to implement in the following videos with you. And this is the first video of that. And I'm trying to explain like the basic structure of my new network architecture. It's like we can still implement like fully connected networks and so on, but they're more flexible. We can implement even more. Like the last one that we had, it was very static. Like we had we had like only one activation function, only one output error function, and so on. And this network that I'm going to show you right now, it is able to, or it is capable of doing like much more. It might be not as quick in calculating, but it's still very quick. And I'll give it a try to show to you. So this was pretty much the basic structure that we had in the previous tutorial, and I'm going to run through all of this quickly again. So we're having like the green input neurons, like we're having the blue hidden layer, and we're having the orange output layer, and the output layer and the hidden layer are doing some calculations. In the new part, I'll show that to you soon, or in some you see it in a while, in a few seconds. That I'm going to have an output layer, but the output layer is not going to do any calculations. To keep things simpler. The input layer was like a buffer in the previous tutorial, and it will remain being a buffer and nothing else. No calculations, nothing. Um, so what we didn't really talk about was like what is actually a layer, and in my in the new structure that I'm going to show to you, a layer will be like a set of neurons, including the wakes connected to the previous layer, because they're really important. The basic concept behind that is that each output has each neuron has an output, like we had before. Like that's like what we had, or what we are always going to have, and how it's supposed to be. But the thing is, we have actually no idea what's inside these in between the layers. Like I mean in between the neurons. Like there could be like wakes, but they're not necessarily there must be wakes. Like there could be something else. We could transform neurons into I don't know what, but it's like the part in between does only tell the output neurons how to calculate the output by using the output of the previous layer. Um, so in this example, we had like pretty much three layers. We had the hidden layer, we had the output layer that did some calculations, and the output layer also, like, we had the neurons and the wakes connected to the previous layer. And all this will be one layer part in the new network. And it's like what's part of it is like it has an output. It has some feed-forward calculation method to take the input and calculate the output. And if it's and it might have an activation function, but not every layer will have an activation function. So for example, the real output layer will not have one. And of course, we are going to have the input layer, and this will pretty much stay the same. But there's no previous layer, um, and there are no wakes, so it's still just a buffer, and only the output of this layer, it will be the input of the network. But I've already said that I don't want the output layer to calculate anything, so I'm going to add a new layer, and this is going to be the output layer. And the reason for that is it's just easier to code at the end, and it's easier to use. Like it's just more structured. But the thing is, like, the output of the output neuron is like exactly the same as the output of the previous neuron. There's no activation function, no wakes. Like it's just a connection, but without any wakes. You can say it's a wake of 1, but we can just ignore that. The output derivative is also going to be transferred to that neuron, and also the error sign of this neuron is equal to the error sign of this neuron. The reason why we have like an output layer that isn't doing that much is because we're going to have like different error functions. And if you remember, we had like we calculated the error at our output layer by using the our activation function, and not our error function, and we used the mean squared error in the last tutorial, but we might change it up. Like I've googled it, and there are like so many layers. There are so many error functions that can be used. Like this is something on Stack Exchange, and it's a list, and we use the quadratic cost, also known as mean squared error. But there's, for example, the cross entropy, and it's actually pretty good. But I'm probably not going to have the time to implement this. But you will see how I've implemented the quadratic cost in the new library, and it's so easy to implement something new. So if you want, you can just go ahead, take my code, and implement a new cost function. Cost function and error function are pretty much the same. So I might have different. Oh wait, I have to go to where we've been. Yeah, we might have different output error functions. So this is going to be plugged in here, and it will do some stuff with the output neurons, and from there we are going to feed it backwards. So we're having like this neuron is part of a calculating layer, and a calculating layer will not have an error function. Only the output layer will have an error function, and therefore it's not going to calculate anything. To keep things easy. So the next thing is what is actually part of the layer. Like I've already discussed this, but what we need for variables is we need the output derivative, and we need the output error signals. And wait, I'm actually not sure what I did here. Okay, yeah, I've already talked about the feed-forward process. So like the input layer is just a buffer. The second layer is just it's in this case a fully connected layer. But you see that the next layer, it is not a fully connected layer. It's just we're having some weights in here, and the thing is that's why it's important. Like it can calculate its own output by taking the connections and the output of the previous layer. The output of the previous layer has nothing to do. The weights in here has nothing to do with the output in here. Like these neurons, they absolutely do not care what's happening with their output. The only thing that influences the output of a neuron is the output of the previous neuron, and that's why the structure is the way it is. And of course, we are going to have the output layer, and we're just going to transfer the output derivative to the output neurons, and in return we are going to just transfer the error signal from the output neuron to the last hidden neuron. And that's pretty much it, and I'm going to implement this in the next video, but I need your help. So like I've already coded everything, and it works really good, but I could go through all the code, but it might be a lot of repetition for you. So like there are some choices that I could make. I could either just like code everything new, and it would take like maybe 5 to 6 videos. I could just show you the full code and explain the full code, which might be you might be a little bit confused because it's there are some things in there that are not that might look complicated at first, but are actually quite easy to understand if you would code it yourself. Or I could just copy and paste like some functions and explain each function and build in a network like that. That would probably take like maybe 2 or 3 videos. So it's your call. Just write it down in the comment section what you would like, and I will go for that in the next videos. And I hope to see you in the next videos.